Okay everyone, this is the lecture 2 of motion in 1 dimension. So in the previous lecture we have stopped at distance and displacement. So these are the first two parameters of kinematics. I hope you guys remember what are the parameters of kinematics. I am giving you a little bit of time to think. There are total 5 parameters of kinematics: distance, displacement, speed, velocity and acceleration. So we have covered 2 parameters. In this lecture also we will be covering parameter of kinematics as much as we can. So we will start with speed. Definitely this was the third basic parameter. So let's start our lecture 2. Okay, so first of all, what is the speed? We will first understand its definition and then we will understand its types. I hope you haven't learned about the types of speed. First, we will start with speed. What is this speed? First, let me discuss the definition. When not when we can describe it in a more appropriate way in the language of physics. So distance covered by particle in per unit time is called speed. So this definition is kind of, you can say, completely based on its formula, or this definition is its formula, and let us understand the speed. So if a object is moving we use the phrase speed like very fast. If the object is going very fast, then its speed is very high. If it is going very low, then its speed is very low. So this is the local language of speed. Well, the language in terms of physics is this. So I hope you have learned about this speed in class 9, definitely. But in this class 11, we will learn more of this speed. Types of speed. Okay, so what is it? There are 4 types of speed. What is the first type? Can anybody tell? The average speed. Average speed. What is the second type? Yeah, this is kind of new to you. Instantaneous speed. First is average speed, second is instantaneous speed. The rest 2 types of speed are, we have learned about it in class 9. There is nothing new in this speed. The third speed is uniform speed. And the fourth is non-uniform. Okay, so let us remember the four types: average speed, instantaneous speed, uniform speed, and non-uniform speed. So we will discuss this in the last part of our lecture, because this is I am assuming that you have learned this in class 9. Where our main focus will be on average and instantaneous speed. So I want that you guys note this part down first. Okay, so let's start with average speed first. Or should we discuss some, you can say, very important points about speed? Let's first discuss some points about speed. SI, unit of speed is meter per second. Well, these are very important points which I am telling you. SI unit of speed is meter per second. What can we say? Formula of speed is distance by, as from a definition, so this is nothing new to us. Well, these are the points which will be used in solving questions from speed. Okay, SI unit formula. Now let us discuss about dimension. Okay guys, what is its dimension? Can anybody think for a second? If we find its dimension, it is going to be in a second. That means L T minus. So, is anybody okay with what have I written over here? Its dimension is LT minus. So these are some very important points related to speed. Okay, so now we can start with types of speed. The first part. Average. It is written like VAV, and we need to note one point. It is a scalar quantity. Speed is a scalar quantity. That means it has no direction. The next topic, velocity, has direction. Okay, what is this average speed? Can anybody think for a second? The ratio of total distance traveled to total time taken is called average. But wait a sec, isn't this average speed definition exactly similar to speed? Does anybody has this question? If yeah, then you are a good student. If no, then you are just listening. So these two are a little bit different talks. Okay, let me explain this to you. How? So let's say this is point A and this is point B. There are some intervals over here. One second, 2 seconds, and 3 seconds. So there was some distance over here, some distance over here, some distance over here. So the normal speed is like adding everything up using no formula at all. We will just sum all of these speeds in different after finding different values. But in the case of average speed, what we done is we make a single formula out of this. That is, whatever distance is traveled, let's say this is distance d, td, total distance, and this is distance, this is time, tt, total time taken, ttt. This is so funny. So the average speed is going to be Is this point clear to you guys? We will discuss some questions related to these. Well, first I am asking you, is this point clear? If yes, then you can note this down too. Okay, so I hope everyone is clear. So now we are going to erase this part down, and we will be doing it all and solving everything in French. So we have discussed the first type of speed. So now we will discuss the second type of the speed. So as usual, it will be instantaneous speed. Instantaneous speed. This is our second type of the speed. So let us discuss its definition, and its definition is really very simple. So the definition can describe you about every of its functions. So the speed of an particle, the speed of a particle at an instant is called instantaneous speed. At an instant is called instantaneous speed. So I hope you understand its definition very well. How do we measure instantaneous speed? There are two ways. One is formula and one is a device called speedometer. So let us discuss about the speedometer a little bit. We use a device called speedometer to measure instantaneous speed. So let me make a little bit diagram of it. It looks like and there are scaling made. This is not a very exact diagram of speedometer. This is just kind of rough, which is used in some many kinds of cars to check out the speed. So this is not very great detail. That's all. So we learned the first way to measure instantaneous speed. We need to fit it to the object, wherever the object is going, and it will find out the speed. So this was the first way. What is the second way? This is to use the formula. Can anybody remember the formula? You have a little bit time, you can think it. The formula is simple. V instantaneous will be differentiation. So what a differentiation comes? ds by dt. S is the distance traveled and the t is the time taken. Definitely the formula part is really very important, because there are many low probability to ask this from the first method. To measure instantaneous speed. The second method is very useful and it can be applicable anywhere. This is the second method. Alright, I hope we are clear with this topic called instantaneous speed. Now we will move to uniform and non-uniform speed. Till then you can note this part down as well. Okay, so I'm going to install now. I will move to some simple topics of types of speed, which are uniform motion and non-uniform motion. The third part. Non-uniform, uniform and non-uniform motion. So these are very simple. We have learned about this in class 9 too, but still we'll understand this. When a particle covers unequal distances in unequal time intervals, then the particle. Then the particle is said to be in dash. I won't tell you this, otherwise it will be not clear to you. What is the correct scenario? You will understand it when I complete the other definition. When a particle covers not unequal again. I was repeating the same statement again. When a particle covers equal distances in equal time intervals. When a particle covers equal distances in equal time intervals, then the particle is said to be in. Okay, so now I'm going to clear your doubt. Over here is going to be non-uniform speed. Well, sorry for one misunderstanding. I tell you about uniform and non-uniform motion. Well, there doesn't exist anything like that. Okay, this is going to be non-uniform speed, and our head is going to be uniform speed. So it is all clear to you. These two were very small topics. Are there any formulas related to them? No, there are no formulas related to them. So you can just note this part down. Okay, I hope everybody note this part down. So it's time to end this lecture number 2 of motion in one dimension. In this lecture we basically focused on the third parameter of kinematics, which was speed. In the next lectures we will continue this chapter motion in one dimension. Even further, there are many topics to be understand, like motion, the gravity, acceleration, velocity, etc. etc. We will cover it all. And thanks